We take the availability of fresh water for granted, but it's quite a luxury, isn't it? Most of us probably don't realize how fortunate we are to have such easy access to clean drinking water. The reality is that over 2 billion people live without safe water. How is this possible? Only 3% of Earth's water is fresh water. The rest is in oceans and seas. Most of this 3% is frozen in glaciers and ice caps, or found underground. Only 1% is liquid fresh water. These freshwater resources need to be enough not only for drinking, but also to support the agricultural sector and livestock to feed the 7 billion people on the planet. Water is a basic human right. The United Nations Sustainable Development Goal number 6 is crystal clear: water for all by 2030. So how can space help us achieve this? Satellites can play a major role in monitoring our precious water resources. They can help us locate and monitor freshwater sources, and even help in predicting water demand. From their vantage point in the sky, satellites also provide key information about many components of the water cycle, as well as monitor plant health for irrigation needs.
We work together, we use data from ESA, specifically data that's coming from the new Sentinel satellites that are being collected in the Copernicus program. We monitor water use in, for example, irrigation schemes, and then we see in which part of the irrigation schemes we have higher yields with lower water use. And if we can find out why that is, then we can try to improve the agricultural practices.
Satellites are also providing us with a better understanding of ice loss. In the Himalayas, high mountain glaciers are thinning due to increasing temperatures. The glaciers in this area provide water for over 1 billion people in Asia. Information from satellites help us understand what regulates glacial flow speed to predict how meltwater will affect the region's supply of fresh water in the future. Space-based research is also used to advance water use efficiency for the future. For astronauts on the International Space Station, recycling water is fundamental. This includes exhaled air, sweat, and even urine, which can all be made into perfectly drinkable water.
Water recycling is a big part of the maintenance of the space station. So 70% of the water is recycled, and also our urine is recycled. So in the space station we can basically say the coffee we drank yesterday is the same coffee we drink today, and is the same coffee that we will drink tomorrow. And we also drink the coffee of our crewmates.
As we explore space and look to voyage farther away from our home planet, we need to come up with new ways of living in artificial ecosystems. That's where ESA's Melissa project comes in. The Microecological Life Support System Alternative aims to produce food, water, and oxygen from waste for human space missions. Its main target is to help us with human exploration of the solar system, but it will also help serve global needs in harsh environmental circumstances.
People consume water more than anything else. So in space as well, we have to supply water to our astronauts. But this is a huge mass. So we are trying to recycle absolutely all wastewater. Melissa, which is a circular system, is aiming to transform progressively all the wastewater in oxygen, water, and food. This led already to some success on Earth, such as the Villa Troglodyte in Monaco, where we are recycling all the water for human consumption, as well in Concordia Antarctic Base, where people are living on our technology for more than 15 years.
Water is crucial to life on Earth and beyond, but with billions of people affected by the lack of water, we need to make changes now to leave no one behind.